Okay, today we're gonna see how easy it is to incorporate Relu into matrix with using Relu with matrix multiplication on a GPU. So we'll just go back to matrix ops. We'll find GPU underscore mat. Oh, right here. Okay, so we can do it on mat dot and mat dot bias, but we should probably make a new function for this because you're not always going to want Relu in there with it. So we'll make a new one, void GPU mat dot Relu. Weird. Okay, so we're just gonna copy GPU mat dot. Everything's gonna be the same. Let's see. Okay, so there's that. Except add in this Relu. And that's going to be the name of our next kernel. So get rid of that. Fastmat dot bias, fastmat dot. We will put it, we'll put it under both. Global void. Okay, so take this mat dot. Which does not want to copy. Put this here. There's only one difference here, one little line of a difference, and that would be max of 0 and sum. Okay, I don't like that there. That's it. That's all you need to get Relu added into that. We can do the same thing with bias. Okay, so we'll add in all of this stuff, which does not want to copy as usual. Throw this in here. And then once again, keep all this the same. Actually, I do wonder if you can just call. No, never mind. I wonder about calling other functions inside function. Calling one function inside of another in a kernel. Wonder how that works. And on this one, we will do standard max of that. And that. And boom, that is it. So all you do is do a max of what you, or the destination is equal to a max of either 0 or the bias, or in the bias one, it's bias plus sum. In the other one, it was just sum. So that's all you need to put that in there. Save that. And then to go to NN, how would we change things to make this work? We could make a new class that is a layer dense Relu. Or we could just do a void GPU forward underscore Relu. And then we would need a that's funny. GPU, let's see, backward underscore Relu d-values. Interesting. Interesting what kind of things it outputs as this prediction. Okay, GPU forward Relu is, so this is half the reason why we did this. It is faster, but also it's going to be helpful for, no, yeah, it was just faster. I just thought of it while thinking about the Relu. GPU forward void layer dense GPU forward Relu. Okay, so there's that. Spices, yep. Else. Okay, cool. GPU mat.bias Relu, did we not make that? GPU mat.Relu. Bias, we did not make a I thought we did. No, we created fast mat.bias Relu. Fast mat.Relu. We did not create a GPU underscore mat underscore dot bias Relu. Boom. Okay, there's that. So it's going to be the same as this. Nope. It's going to be the same as this. Mat.bias. That's annoying. Copy that. Mat.bias. I'll have to double check the fast. Oh wait, no, that's not what I want to copy. Okay. GPU, mat.bias. GPU mat.relu. Mat.bias relu. Okay, so mat.bias is what I'm looking for. Mat.bias. Okay. This is what I'm looking for. To go down here. But this would be fast mat.bias relu. Control save. Now it's there. We're good. This will change the backwards pass. Both of these will. Both of these things will change the backwards pass. And let's see how it'll change the backward pass. If we find Relu, the backward is right here. So since we combine the two, we will also need to combine this backward with it. So we can do Relu D inputs, go back up here and have a Relu D inputs. Okay, time to turn this off. Okay, cool. So Relu D inputs, we can calculate those and use those as the D values. Kind of thing, or we could leave them as D inputs. Maybe create D inputs off of it, calculate the new D inputs off of the old ones. Let's go back to the backward pass. Okay, so you'd have to do D inputs with that. Okay, yeah, no. Let's go ahead and do void layer dense backward Relu mat D values. I'm just doing this as I go. In the future, I'm sure I will have better optimizations. For example, all this backward stuff. Eventually, we're going to want to put that in GPU as well. But right now, in order to do some of the optimizations, we're just going to have to work through what we got here, because I'm still working on, I'm kind of just going through this process as I'm making these videos. A lot of stuff I already know, but some of the stuff I'm still creating on my own. Okay, backwards Relu. Let's start with Relu. Find Relu. Find your Relu function. I'm just going to copy this. And then we'll go back up here to wherever it's at. So if you're going to do it like me and copy the inputs is now going to be Relu the inputs, copy, paste, paste. Okay, so that does layer inputs as well, which its layer inputs are going to be the outputs. Going to be output. This will be Relu D inputs. This is output because we're in the layer dense, so we're using the output of the, oh, actually I do wonder if that, will that work? No, yeah, that will work, because less than or equal to 0. Okay, yeah, it will be output. Because we're in the layer dense. The output is the original layer dense output. Actually, no, it's not the original layer dense output because we have applied the Relu to it. But it doesn't matter because this output, anything, the original output was positives and negatives. And all the negatives we set to 0. Well, on this one, we've set them to 0. So this is going to say, okay, this is equal to 0, less than or equal. So the ones that we've set to 0 will catch here. They used to be negative. Either way, that'll catch here. And map these Relu D inputs to 0. Okay, so let's say we do this first. And then we go through. Can I just say backward Relu D inputs? Does that allow? I think so. I feel like yes. I guess we'll find out. Okay, so we do that. We have an issue right here. Rows and calls. I don't think we have allocated it yet though. In the constructor. Now if we do this, if we do it this way and we allocate memory to Relu D inputs, the issue is you're doing stuff you don't need to. When you're doing a layer dense without Relu. So we could add in another one. Comma, add bool, add Relu equals, no, add Relu equals false. We don't need another one. Sorry. We don't need this. Let's just add in a bool. Add Relu equals false. Set it to false. If you forget it's there, you won't use it, and it's set to false. So you're good. Comma, bool, add Relu. Oh, there we go. We'll do an if add Relu D inputs equals mat alloc. Be the same size as output in samples by in out. So that should be everything, I do believe. Okay, backward, forward. You get it straight into output. So nothing extra needed there. This is the regular backwards. Okay, this one has Relu. We've allocated to Relu D inputs. We're good there. And then we'll hit backward right there on Relu D inputs. Nice. Okay, since we're talk a little bit about some optimizations, I would say layer inputs transpose is one area where unoptimized. Just to throw this out there, it's in the backward pass here. So I'm sure there's another way you can do this. Rather than creating a whole new matrix and filling it, you would, let's see, maybe just have some, this would probably be a matrix ops. You would just access it in the transposed way. That would be easier. Maybe not easier, but you're not using this extra thing. So yeah, you probably just have to make a new mat dot. So maybe this is the easiest way. You'd probably have to make a new mat dot as like a mat dot backwards. That would itself transpose this, or transpose the use of this, if that makes sense. But I'm not going to do that. That's extra. Okay, so we got that. Got that all in there. Atmel. Okay. let's try these two things. If we do this, there's no exact way of testing that they'd be the same as we've created the code right now. We can check the forward methods to be the same, but the backwards, can you do both of the backwards? Relu and backward. D weights to be 0. We could check D weights afterwards, and D inputs. Let's check this mat dot. Yeah, that's a way to optimize all this. Could make this GPU mat dots on the way back. Weights to D values, D inputs. Trying to think of if it's going to mess things up too. It could. I'm sure it does not. Mat dot. Go back up to mat dot. Destination plus equals. D inputs. Okay, so it's D values, D inputs. Okay, it gets zeroed out right here. That's what I need. Gets zeroed out, and then you add to it. Okay, so that's what we need there. So we're good here. We can go ahead and go over here and do a mat.bias. Okay, so let's do GPU mat.bias. We don't need this one. Okay, so this is going to be destination, and we'll use destination CP. Let's call this Relu. Not mat.bias. Okay. Just kidding. We don't need these. So we've got our input. Let's call the input just A. Yeah, we don't need you guys. We are just going to use a layer dense. Okay, it helps if we include an N. Include nn.cu layer dense ld. All right, what do we need here? Layer dense takes in input, output, bool, num samples. Not that one. Input will be a calls, so it's 3. Output is, what does it call it, 2. Bias true. Num samples is equivalent to 8 rows, so that is, oh, we can just put 8 rows there. Here we will put a calls. This we don't have anything for, because we don't have an output we're comparing to. A rows, comma, leave that. Later dense ld Relu, it calls to true, 8 rows, comma, true. Okay. So now if we do ld dot forward of a, and we match print, no, sorry. We also need a Relu here. Is it Relu activation, Relu? What do we need for this? Find Relu, control find Relu. There's all sorts of them now. What if I do activation? Num samples and number of neurons, so number of sample and num output. So this will be a rows, and we're just going to put num out, which we are going to make is equal to this too. And num out 2. So that means this will be num out. Alright, what's the issue here? Not a type name. Weird, but okay. And this will be also num out. Okay, we're gonna do a forward. We're gonna do a Relu dot forward, and that will get us ld dot output. Okay, so we're gonna have Relu output, print Relu dot output, and then down here we're gonna do ld Relu of a. Alright, what am I missing? Oh, forward, my bad. Forward a. And then we're going to match print ld Relu dot output. standard cout. Call this LD Relu out. We'll call this standard cout LD out, LD and Relu separate out. There we go. And then LD Relu out. Let's save this. Save this. Save this. And we do F7. Make sure it all works. Okay. Got a 0. We're good. CD build debug main LD and Relu separate out, LD Relu out. I don't know why it says they match. Just because that's down there. .14, .02, 2.026. If I do GPU forward. Oh. Okay, well there's one thing. So we'll save that, F7. Okay. Okay, 0 and 0.15 versus 0.002 and 0.02. Okay, definitely wrong. GPU forward. Dot vice Relu hold up, did I let's make these false. Oh yeah, they're not going to be the same. First of all. No, that's not what I want to do. Okay. So LD LD. Okay, so we have an LD in Relu, an LD. Yeah, this makes perfect sense, actually, because they were completely different layers with completely different initialized weights. Is this going to work? LD output will be changed on that one. So yeah, it should be good. And there we go, the exact same. So now we check the backward, where we do LD dot backward of LD dot out, let's say Relu dot output out, LD back, and match print LD dot D weights. D weights, standard cout, LD D imp, okay, next we will LD dot backward Relu on the, we can do Relu dot outputs, doesn't matter. And then, okay, we're just gonna copy that. LDR D weights and LDR D inputs. Is that right? Oh, I guess I need match print D LD.D inputs, and same here, match print D inputs. Save that, F7. Okay, terminal, go hit main. Is it the same? These two are the same. This is not. Oh wait. Did I forget to save something? The Relu out, LD, D-way, D inputs. Save, F7. So something went wrong on the backward. F7 that. Save, or sorry. Not F7. Comment out that. Save F7, see what happens. Backward. Okay, so we have an issue on this backward Relu. Something it does not like. And it's possibly this. If I were to do this, would it work? Control save, F7. Still doesn't like it. What do you not like? Does the output say? all it says. Just gonna rest. Interesting. Okay, so we can get rid of these two. First of all, don't need you either. Okay. We have D values coming in. Okay, so we stole this right from Relu. Relu underscore activation. Go to the backward. Okay, we have Relu D inputs, Relu D inputs. Let's do this. Control save. F7. Okay. Does it work? No. We get, let's go ahead and stop printing these. Control save, F7. And then it just stops. Okay. Relu output, and that's the same Relu output. Backward Relu. Doesn't. Okay, what if we just comment out all of it and work from there? It doesn't like something. D values. Comment out everything and make sure that works. Save. F7. Terminal. Okay, so that works. What is it? That you don't like? We'll go one section at a time. Save. F7. And then play it. It does not work. Interesting. Of the D inputs. Interesting that it's still going. Of the D inputs. Relu.d inputs. Oh, we don't have it. Okay. That's why. Once you find it, it's obvious. We had add Relu as false up here. So we are going to make as true. Save. So it was just found some number, whatever number was stored in there, did a for loop of maybe something, maybe nothing, and there was nothing there. So yeah. Okay, save F7. And LDR D-weights. Okay, cool. So go back. Put that back in, put this back in, save, and print these as well. Save F7. Done, and play. What do we have now? Okay, so we have points. We have 0, 0.5, D-way, D input, 0.598 for D-way, 0.0019 for D input. All of it exactly the same. Perfect. See? That is a way of incorporating Relu into that. Obviously, I left out plenty of optimizations in the backwards. I mean, I'm sure this can be thrown into kernel. Where did I go? Okay, backward can be thrown into a kernel to optimize both of those. But I'm not saying it would actually be helpful to throw each of these into their own separate kernel. That might, depending on the size, actually take more time. Just because of the time of setting up the kernel, launching all threads and all that might actually take more. But putting these two together into a kernel might be useful. Probably would be useful. Yeah, and hopefully eventually maybe what is most useful is putting more than one together. I haven't tested or looked into that yet. I know layer with activation function you can put together, at least with Relu. Put that together makes that would make that faster. Other activation functions I'm sure you could throw in with the layer dense, make it faster. But yeah, the backward, all these mat dots could be kernel, could use the GPU version. I don't know if it would speed it up. Like the ImageNet probably would not speed it up. Maybe it would, I'm not sure. We will have to find out. But I guarantee it would be better to throw all of this, make all of that into one kernel, would be way faster than separately, putting it into separate kernels. Yeah, until next time.